This conference will now be recorded.
Welcome everyone to the ESIP Education Out to Lunch series, organized by the ESIP Education Committee and hosted by the Earth Science Information Partners. My name is Becky Reed, and I'm honored to introduce John Pickle, who will present Earth Systems activities available on his website, Science Pickle. Go ahead, John.
Thank you so much, Becky. I appreciate it. Today, I'd just like to do, three basic things. Show you the range of activities available, the topics on the website, and demo the website and some of the software. So what we currently have on the website are written materials, data analysis and visualization activities, inexpensive experiments, simulations, games, and self-graded assessments. And the current topics are first, learning to learn experiments, really focused on students, helping people think about finding the best tools that help them to learn for their learning styles. Concept mapping, data contouring, and then the first of hopefully a number of semester-long courses to be developed, Earth System Science. And so as we go through this, I'd like to demo the website and software, but I appreciate, and since it's a new website, suggestions you might have for your own use in a classroom or any version of education you have. So it's going to the website. First off, so we have the home page, the learning activities at the top, concept mapping, contouring, Earth Systems, and then the summary of the software that's available right now. Currently, I'd like to focus on the Earth Systems components. That's where the supporting software is, but I really encourage you to take a look at the other topics. In Earth Systems, we have the beginning parts of what is a system, Earth's coordinate system, energy, Sun-Earth connection, star-planet connection, vectors and forces, Earth, wind and forces, my tribute to Earth, wind and fire, atmosphere, clouds, and precipitation. So let's just pick a topic. Let's take a look at the energy page. So you usually start off with, a brief overview, the main components of energy, in this case, phases of matter. And then we get down to the basic 5 mechanisms for heat transfer between objects: conduction, radiation, advection, convection, and latent heat. And in here, in this process, we have the black body radiation simulation software. And what this does for us is thermal radiation is very complicated for students to think about. And so for a variety of reasons. We don't even know what most high schoolers really don't have a good handle on what light is, or the electromagnetic spectrum, let alone the 5 different ways light's generated. Here we're focused on thermal radiation, or black body radiation, which is the broad spectrum emitted from objects with a temperature above absolute zero. Now, it's hard to fathom such a broad range of wavelengths being emitted from an object. So we have a self-adjusting linear scale, but then we have a logarithmic scale. And here, when we change the temperature of the object, the scales don't adjust, but obviously the line changes. But then we can compare it to known objects, such as the sun. And in this case, we see that the sun is a little bit colder, and we have a different type of curve. Now, to help layer information, we can bring up what is the range of electromagnetic spectrum, the categories that we're seeing. So we see that at this temperature, the sun doesn't emit X-rays, emits a small amount of ultraviolet C, a fair amount of UVB, UVA, our bread and butter visible light, and then the infrared. And what we get here is we can actually get more details. So one of the things in presenting and exploring complex information, you can turn information on and off to help people see various information when they want to drive it versus having too complex a graphic to start with. They get to change it and explore it in a sense what makes sense to them. Now in this, we also have various challenges. So in this case, you can pick basic questions, try to use the graphics, the interactive to answer them. And then once you're done, you can actually come down here to the Science Pickle and click on it, and you get the answer. Plus, you get the big ideas for that activity. So here we have 3 basic activities: explore, past and future sun, and radiation budgets. And what I kind of love about Earth systems is the sun is actually getting hotter. And so its wavelengths are that the Earth has received over time and will receive over time is changing. And here you can get an idea of, you can start to take this information, and as you learn more through the Earth systems course, you might say, oh, this will be impacted first, or, oh, how did we actually survive a colder, dimmer sun when life started to form? And next is the ultimate part, is radiation budgets. The rate of energy coming into a system, of radiation energy coming into a system compared to the rates of energy coming out of the system. And what I love about this is you can pick various materials and take a look at how the energy budget changes, the radiation budget, but you also get an idea of the timing. So here, the radiation absorbed, which means the incoming sunlight with respect to the reflectance or the albedo of light, and then the energy budget being emitted, the radiation being emitted from the surface as it gets warmed. And here we get an idea over a grassy field. It doesn't get too warm. However, in addition, the warmest temperatures occur at about 1500, 3 o'clock in the afternoon, compared to when the sun was highest in the sky, which would be at local noon. And that's much different compared to things like the pavement, where we have very hot parts of the day right at or very close to local noon. So you start to get an idea of what budgets mean, because that's going to be what drives energy processes. After that, we move on to, let's just take a quick break here. And before we go on to that, I'd just like to summarize how the software is designed for educators. So what you get are self-generated visuals, and hopefully as you saw that, you can layer the information being packed onto the graphics, helping students and you present information. There's a lot of interactivity. People get to change variables and see the response. There's a significant amount of data analysis and graphical presentation of information. And ultimately, the software is designed for what-if scenarios. What would the Earth be like if? What would a planet be like if? And finally, you can save your work to include in homework or tests. You can generate the answer keys as well, highly visual, and students can save the work and include in their own homework or research papers. Moving on to the Sun-Earth connection. Part of this, of thinking about Earth systems, is a matter of perspective. So here what we're looking at is our Earth orbiting the Sun, but here it's a top-down view. And we can change that to look at the Earth from the side, and we see how the Earth's tilt or obliquity impacts what latitudes are being illuminated at a given time of the year. And from above, we see the same thing. And here we can see, oh, this latitude, 67 degrees at January 1st, is in darkness the entire day. It starts to set up the discussion, oh, the poles will definitely have an extended period of darkness. And conversely, about 6 months later, extended periods of daylight. And not forget about the South Pole people, Southern Hemisphere people. You can view the Earth from below in its orbit. Now that's just looking outside our solar system and our orbit, but then we can start to take a look at how the different parameters change here on Earth at given latitudes. And there's a wide range of activities of data you can explore. Illumination at local noon, illumination at sunrise, sunset, hours of daylight, local noon sun angle, peak solar radiation, and total daily solar energy. And again, you can layer certain information on, and we can explore. Now, obviously, we don't see the Earth orbiting anymore. And that's why the sun rays coming into a given latitude appear to change. So in a sense, from our perspective, we're not the ones moving, it's the sun. But this is a way to start to think about, it's Earth rotating and orbiting the sun that creates the seasonal and daily illumination patterns that we see. And from another perspective, we can start to take a look at declination circles and get a tremendous amount of information of how the sun changes. And we have a north-south view, which means that looking into the page right here, we'll be looking eastward, and looking out of the page would be westward. And to help us think about that, we can actually change it and look east to west and see the solar declination circle, as well as the time of the hour positions of the sun during this time. And we can also take a look from above, and we can start to get an idea. Here we would be in the center, and this is what we would see in the course of a day. And then we can extend this using hours of, take a look at the yearly trends and compare latitudes. So, and finally, we can apply it. And so one example would be awnings. Design awnings so that during certain times of the year, we get sunlight coming into a house, warming the house on the inside, but in the hotter times of the year, we can design awnings so that light is blocked out. So if we work with this, we can actually illuminate light coming into a house during the equinox and the summer solstice, but we could design it so we get a lot of sunlight.
John,
yes,
I'm gonna just break in here because I think we might have some questions.
okay.
And this
Yes,
is
I was just done. So
oh,
thank you.
I'm sorry. I should have read that you were just about to finish up. I love how practical that is, and they can do some make some practical challenges. I'm going to unmute everybody now and see if I can unmute everybody. Nope. I think you are all unmuted.
I'm still here. Can you hear me?
Yeah, is anybody else able to speak? Or can unmute themselves? Or you could put a question in the chat and I would read that.
Mm-hmm.
Shelley Olds is writing.
What's the time scale?
Yeah.
So the time scale for the sun getting warmer. Great question. When it first formed, it was about, I've seen different estimates, 60 to 70% dimmer than it is now. And if you work that out, it's roughly getting 10% brighter every billion years. I mean, it really presents a conundrum of how did we stay warm enough? But then we start to see we had much higher greenhouse gases early on. And there's a significant amount of research trying to determine why didn't we freeze over with a dimmer sun? And we didn't, because we know life has evolved on Earth by at least 3.8 billion years ago.
That's awesome.
Hi, John. This is Alan.
Hey, Alan, how are you?
I'm doing good. That's really That when I first saw the software, that was one of the things that struck me as fascinating. How the sun has behaved and what the factors are. How that affects the ancient or geologic history of the
Yes.
Earth.
Yeah, and then what's going to happen in our future? I mean, I guess when I first got into geology, we often looked at today and thought about that as kind of a representation of the past. And it's like when you think about an Earth system perspective, we know that some of the key players that drive the energy flows and the matter cycles and the life webs weren't there or were quite different, through Earth's history.
All right, it is time to wrap up.
It is. I much appreciate this. Thank you, Becky.
Yeah, and we intentionally keep them short, but this was a great piece, and I shall put in the chat your website. But I'd also like to remind everybody that on March 27th, we're going to do Weather and Climate Web Apps with Tom Whitaker. Same time, same place on March 27th, and you'll get a invitation in your email.
Great. Thanks so much.
All right, thanks, John, so much.